بسم الله الرحمن الرحيم. السلام عليكم. In this video, I want to talk about ensemble learning. Ensemble learning means combining multiple learning algorithms, and usually combining multiple learning algorithms has better results than one algorithm. Okay, here you see that we have the data. Here you see that we have some machine learning models, model 1, model 2, model K, and this is the ensemble model. The ensemble model is the combination of some models. Okay, so we have more than one model that are working, they are being trained, and they are used in the test phase for classification. And using these models, we are making a prediction. Usually, as we said, multiple models have better result than one model. Combining learning algorithms could be done for classification or clustering. So we could do the combination of learning models for classification and clustering. Okay, classification and clustering. Both of these two fields can use the combination of learning models. Here we want to talk about the ensemble of classifiers. Okay, so in this slide we want to talk about the ensemble of classifiers. We have some classifiers and we want to create an ensemble. When we want to create an ensemble of classifiers, we should note that the classifiers should be diverse. What does this mean? It means that they should have different results on the same data. They should have different results on the same data. If the classifiers have the same results on all data, it means they are not diverse. So diversity means we are having different results. This is very important. If the classifiers are not diverse, then combining these classifiers is not a good idea. Okay, we have different models for ensembling classifiers. We have different methods for combining classifiers. These different methods are listed in this slide: bagging, random forest, boosting, stacking, and mixture of experts. These are some of the methods that are used for ensembling or combining classifiers. Okay, we start with bagging. Bagging is a type of ensemble which we are combining a number of classifiers that are the same type. For example, we are combining 5 KNN classifiers, or we are combining 5 decision trees. So this is called bagging. We have one type of classifier and we have a number of that classifier and we are combining them together. Okay, you may ask that we said in the ensemble learning we should have diversity. Diversity means difference between the learning models. How could we have different learning models when all of them, all of the classifiers are of the same type? How could we have different learning models? The answer is that in bagging, we are training the classifiers on different data. We are training the classifiers on different data. So the data is different. This is a type of diversity. When we are training one type of classifier on different data, we would have different classifiers. Okay? And this is one point about the bagging for combining classifiers. The second point is that the result the result of the classifiers are combined using majority voting. What does this mean? It means that, for example, if we have 5 neural networks and we have combined them together, then we want to classify one data. This data enters these 5 neural networks, and each of the neural networks give a prediction. For example, if we have 2 classes, the first neural network says class number 1, the second says class number 2, the first says class number 2. Okay, for example, 3 of the neural networks say the class 1 and 2 of them say class 2. In this situation, the majority voting says that class 1 is the prediction. Okay, so when a data comes and we want to classify it, we use majority voting. Each of the classifiers give their vote, and we see which vote is the majority. Okay, that's the important thing about bagging. Bagging in the classification is done by majority voting. Okay, in the bagging algorithm, okay, as the same for all of the machine learning algorithms, we have a train phase and a test phase. In the train phase, we are building L classifiers. In the train phase, we are building L classifiers. Okay, we select a random part in each of for each of the classifiers we are building in the training phase. We select a random part of the data and then we train a classifier using that data. Okay, so we select a random part of the data and then we train the classifier using that data. So that's the training phase. We select a random part and we train a classifier, okay? And then in the test phase, so for example, in the train phase, we build 5 classifiers, and each classifier is learned on different data. And in the test phase, for each test data that we want to classify, the data is given to all of the classifiers and we get the prediction of each classifier. The final prediction, okay, so we have the prediction of each classifier and the final prediction is the majority vote. The final prediction is the majority vote. Okay, random forest. The next type of ensemble of classifiers is random forest. Random forest is a bagging of decision trees. Okay, so in the random forest, the model of the model of the ensemble is bagging. We are using bagging. But the classifier which is used in the bagging is decision tree. So we are combining a group of decision tree and we call it random forest. Now, why do we call it random forest? What is this word random come from? In the random forest, when we are doing the training and we are building the trees, if you remember, in the decision tree, in the training, we are building some trees. In random forest, when the tree, when we want to build the trees, in every inner node of the tree that we want to have the best attribute, you remember, in the decision tree, the tree had some terminal nodes, the leaves, which were the outputs of the data, and it has some internal nodes, which have the features. In the random forest, when we want to select the best feature to put in the internal nodes, we do a random selection. Okay, we select a random group of attributes, then we select one of them. Okay, so that's why it's called random forest, because we are using we are building the trees using a random group of attributes. So this was random forest. So in the random forest, we have a bagging of decision trees. Okay, so until now we have talked about two types of ensemble learning, the bagging and the random forest. I will talk about this subject in the next video. Thanks.